So the problem set from Sunday was 13 to 14, 20 to 21, or 20 to 31, 32 to 35 in worksheet 1. There any questions about that stuff before we kind of pick up and get moving here, Lily? 24, you say? Sure. Okay. So it says to determine or use the factor theorem to determine if the binomial is a factor. So all we're going to do, since this is monic, all we need to do is to do the synthetic division on this. So since that factor is degree 1 with leading coefficient 1, there's nothing we really need to do. So I set this equal to 0 and solve to get -1. And then I'll set up my synthetic division and just rip that right on through. Since the remainder is 0, we're good to go. Does that make sense? Where it gets a little bit trickier is like 23 and 24, where the divisor isn't monic. But if you set those equal to 0 and do the synthetic division with that result, it'll work. The catch is that what you get back isn't exactly the quotient. But since all it's doing is asking us to determine whether it's a factor or not, it's fine. Okay. They're still just looking for remainder 0. Does that feel okay?
Yeah.
Okay. Ariana? Yeah, sure. Okay. So I'm just going to grab that page. So it says that we want to write the lowest degree polynomial function in standard form that meets the indicated information. So I have x minus 2 is a 0. X minus 1 is a double, so it has like a multiplicity 2. And the leading coefficient should be 2. Okay, so from the x minus 2, if I set that equal to 0 and, if I take x equals minus 2 and I make that equal to 0, I get x plus 2. If I have x equals -1 and I make that equal to 0, I get x plus 1. And since it's a double, I'm going to get that twice. So far, so good? Ariana?
Yeah.
Okay. If it's not, like, stop me, and even if it's like a why are you doing this, not like, okay, I understand what you're doing, feel free to stop me. So now I'm going to multiply all 3 of those factors together that I've just taken care of. And since that's, when I multiply all those equations together, since they're each equal to 0 and I multiply all 3 of them together, they're still equal to 0. And now all I have to do is FOIL this out. So I could multiply these 2 together first, let's say, and then can multiply it to that last one. So I get x cubed, x squared, 3x squared, 3x, 2x, and then 2. So combine my like terms, 3x cubed plus 4x squared plus 5x plus 2. So far, so good. The one thing we haven't dealt with is that the leading coefficient should be 2. So I'm just going to multiply the whole thing through by 2. And that will take care of that. And again, if I think about this, what I've really done is if I multiply by 2 here on both sides, it's still equal to 0. So all the zeros are still in the right place. So that's the same thing as just multiplying the 2 through at the end, which is usually the easier place to do it. It's just because it's a quick distribute. Does that feel okay on what to do there? Okay. Yeah. Anybody else with questions from these things that we've been working on? All right. Well, today we're going to finish up chapter 13. What's that going to mean for us? Yeah, we're looking at the test this week. Probably Friday is the plan right now. Wouldn't be earlier than that. So we'll finish up chapter 13 here today in class. Take Wednesday for the review day, and tentatively Friday will be the test day. For us anyways. The B class will have it on Monday or whatever. All right. So what we have been working on here the last few days have been finding zeros for polynomials. So what I'd like to do is just kind of run through a couple examples here and then give us some time in class to really do some practice on this topic, because, well, it can be a lengthy procedure, but it's not so bad once you kind of gotten the hang of it. But, you know, practice helps, right? Okay, so when we say all the zeros, that's a good indicator to us that we could have like imaginary answers, we could have irrational answers, we can have multiplicities, like basically all the worst things possible that could happen, right? If it says find all the real zeros, then at that, you know, you don't really have to worry about the imaginary stuff. So it's a slightly easier problem. But here we have all. Is okay? So the first thing that I'm going to do is figure out how many zeros I'm going to be looking for. So the fundamental theorem of algebra tells us that I'm going to have the number of zeros should equal the degree of the polynomial. So I should have 4 zeros. Now those 4 zeros count x-intercepts, they count multiplicities, so it's like 4 total, but you got to count everything. So far, so good. And the way we're going to generate these 4 zeros, well, we're going to start by using synthetic division. In order to do that, though, I need to figure out what even numbers would be good things to do the synthetic division on. So I'm going to create a list of possible rational zeros. Remember, your possible rational zeros are in the form plus or minus p over q, where p are the factors of the constant term, and q is the factors of the leading coefficient. So my possible rational zeros then are going to be 1 over 1, 5 over 1, 7 over 1, and 35 over 1. And then I'll have 1 over 2, 5 over 2, 7 over 2, 35 over 2, and then 1 over 4, 5 over 4, 7 over 4, 35 over 4, and then my last set, 1 over 8, 5 over 8, 7 over 8, and 35 over 8. That's a lot of possibilities, right? What do we got? 16 possibilities there. What are we going to do to kind of narrow that down? God bless you. You're welcome. We're going to look at the graph, because I know that x-intercepts will tell me zeros, although zeros aren't necessarily x-intercepts, right? We talked about that last time. So I'm just going to start by typing in my polynomial into my calculator in the y equals menu. Then I'm going to graph this. I don't know what the last thing I graphed was. Probably was for another class. So I'm going to do zoom standard to graph it. That's just going to reset my window to the normal -10 to +10. Okay. So if I look here, it looks like I have 1, 0 here that's somewhere a little bit less than -1. If I look at my list here, 5/4 is -5/4 is a little bit less than -1. So that's probably a reasonable one to try to use. And if I look over here, this one looks like maybe is +1/2 or +1/4. It's hard to tell. You guys agree with that? Though we're not quite sure which one of those two. Is everybody okay so far? All right. So I'm going to make a little space here where I'm going to write down my answers as I find them. So if it's me, I'm probably going to start with the -5/4 because I'm pretty sure that's what that has to be. There's nothing else that's close to that, right? 7/4 is almost 2. 5/2 is over 2. I know it's not -1 because it's definitely not right on that -1 bar. 7/8 is, or -7/8 is too big, right? There's nothing else that really is close to other than -5/4, so that's why I'm going to use that one. And I'm going to write it as a decimal because, well, that fraction looks pretty inconvenient to deal with. And I'm just going to grab my old calculator here to double check some of my arithmetic, just so that I don't make any bonehead mistakes here with my mental math at 8:10 in the morning, which, you know, if you're going to make some mental math mistakes, these are the kind of times when you tend to do that sort of thing. So let's see. That's -36. And now I got +45. Got -90. gives me positive 35. All right. So I'm going to record that answer. And you could record it as negative 1.25, or you can record it as negative 5/4. Either one is fine. It doesn't matter to Mr. Kulik. Is everybody okay so far? Now I'm going to use my quotient and start another, or do another synthetic division. And now I'm going to have to choose whether I want to use 1/2 or 1/4. I'm going to choose to use 1/2. And again, I'm going to write it as a decimal. You could write it as a fraction. It's not wrong, but like, you know, I'm just choosing to do it that way. All right, I picked the right one. It's almost like Mr. Kulik knew what the answer was going to be and didn't want to do an extra one just for fun. I did know what the answer was going to be. Just as an aside, after I do the synthetic division, say I had done 1/4, what would have happened? How would I have known that I wasn't the right one? Say like I did the synthetic division with 1/4 here instead of 1/2, which was not the answer that I was looking for. What would have happened when I did the synthetic division? How would I know when I finished that that one didn't work? Yeah, the remainder wouldn't be 0. Okay. Now, in a case like negative 1.25, if I got a non-remainder 0, I would probably chalk that one up to mental math, like an arithmetic mistake, and go back and double check and make sure I didn't make an error when I did my synthetic division, because Lord knows that can happen. But if you don't get a remainder 0, sometimes it's because what you're trying to synthetic divide with isn't actually a 0. And sometimes it could just be you made an arithmetic mistake. Try not to make arithmetic mistakes. It makes the problem much easier if you don't do that on a regular basis. Okay. So I want to point out to you here that it was really important that when I did my synthetic division, the second step, that I use the answers from the previous step. Okay. If you do not do that, if you just start over with the big polynomial, you're going to be in big trouble here, because now what we have, remember this is a remainder constant term, x coefficient, and x squared, is I have a quadratic that I can set equal to 0 and solve. Since I only saw, when I looked at my picture, 2 x-intercepts, right? And they're both straight, so I suspect they're going to be used only one time. Leads me to believe that we're going to have some imaginary answers here. And the only way to find the imaginary answers is that you whittle the thing down to a quadratic, and then you can use your quadratic formula or something on it. Is everybody okay with that? But I'm not going to use the quadratic formula. Ooh, forgot my x there. Square away on this, because I noticed that there's something I can do to make the quadratic formula a little bit easier here. Does anybody else see it? I'm going to divide both sides by 8. Since I noticed that 8, 32, and 56 are all divisible by 8. Now, it's not necessary that I did that. The quadratic formula will still work, but God help me, that's a heck of a lot easier numbers to plug into the quadratic formula if I have all single-digit numbers, right? Okay. And then the quadratic formula, do you guys remember this? What's the formula? Oh, brother.
Quadratic formula?
Yeah.
Oh, I know that one. That's x equals negative b plus or minus the square root of b squared minus 4ac. That's over 2a. 2a, yeah.
Way to steal the thunder at the very last moment
I didn't
there.
remember what the last number was. Give me that, Eric.
But that's the quadratic formula. If you don't remember that, you may want to reacquaint yourself with it. I probably at some point you did have that memorized. I realized that was probably last year. But this is a good one. It's one that we expect kind of from Algebra 2 on that you've got committed to memory there. So just filling this back in now. So our b is -4. Our a is 1. And our c is 7. Okay. Everybody so far so good? I would just type this into my calculator here. And the way I'm going to type it in, I'm going to do it all in one line. But I'm going to use the fraction command. So I'm going to say alpha y equals to get me the fraction. And then I'm not going to do like negative of a negative. Like, shoot, I know that's positive, right? And your calculator can't do a plus or minus, so I'm just going to do them one at a time. So I'll do plus first. And then I'm going to have -4 squared. Now, I want to point out, you guys, this mistake I see frequently made, particularly in this course. Is there a difference in your calculator between if you write does your calculator recognize the difference between these? Absolutely. They are not the same thing. Which one is the one that you want to be typing into your calculator for this problem? The first one. If you type in the second one, this one's going to give you positive 16. This is going to give you negative 16. This one makes Mr. Kulik sad. This one would make Mr. Kulik happy. My life is sad enough. I don't need you helping me out there. Okay? All right. 4 squared minus 4 times. I'm just going to skip typing the 1 because right times 1 doesn't really need to be there. You guys agree? Okay. And I get an error because it's non-real. That's okay. I'm going to quit. I'm going to go change my mode. Notice your mode has this option down here that has A plus BI. I'm going to go ahead and select that and just retype that. Oh, interesting. What's my problem now? Data type. Interesting. I would not have thought that it would give me an issue with the... So I think the issue is it doesn't like that I'm putting an imaginary number in a fraction. I think is what it's complaining about here. Interesting. I was not expecting the calculator to give me an issue with this. Is there a way to recover this, I wonder? I'm going to try, oopsie daisy. You just try doing that. It's still going to give me the same error, right? When I hit go to, it still directs me to the fraction. Boogers! All right, scrap the idea of typing into your calculator. We're doing it by hand. Oh, no, it's fine. It's fine. -4 squared is just 16. 4 times 1 times 7 is just 28. No big deal. 16 minus 28 is... is... 16 minus 28. Negative, yeah. 12? It is 8:15 in the morning or something, so it's 12 or 20. Oh my goodness, time's just racing by here. So there's that, right? Now what do we do with the negative under the radical? Makes an I. And then we should try to reduce that radical. I notice the square root of 12 can reduce. Who remembers how we reduce a radical? You could draw the factor tree, sure. Or is there a perfect square that divides 12? Or is a factor of 12? 4, right? Your perfect squares are 1, 4, 9, 16, 25, 36, just the number squared. So I notice that 12 is 4 times 3. So the way I'm going to think about this then is square root of 4 times square root of 3, right? And I'm writing way more than I need to, but that's because, well, it's a review problem, right? Probably been a minute since we've done that. Everybody's okay with that? And then I notice that I can reduce this fraction, right? So I'm going to break this fraction into 2 separate pieces, just with a common denominator. You guys see that? It's okay to do that with add an addition or subtraction symbol, because that's how you add fractions, is you make a common denominator with the 2 fractions to write them as a single fraction. Or you can take one fraction, break it up into 2 pieces with the common denominator, right? So 4 divided by 2 is 2, and then here the 2's can reduce. And there's my last 2 zeros. 2 plus or minus I root 3. So let's go back and put that in. Add a space for this way up here, right? Yeah, there it is. All right. That's like the last kind of thing that we needed to do in this chapter. So at this point, you should be able to finish the problem set, which is 36 to 53. Yikes. It's okay, guys. Do you want to... Let's do a couple here just as examples together, right? So I'm just going to grab a couple from the problem set, and we'll kind of kill 2 birds with 1 stone here. We'll get a little bit of practice, and we'll finish part of the problem set. Sound good to you guys? All right. So let's do... Oh, they're all so easy. Well, I don't know. Who's got a favorite number between 36 and 53? Tyler.
42.
Yes, that's the answer right there. Anyone else get the joke? Ooh, more than one person. That's great. So for those of you that are like, what's the joke? I don't get it. There's a book called The Hitchhiker's Guide to the Galaxy, in which hyper-intelligent beings build a computer to answer the question of, like, what is the meaning of life? And the answer that the computer outputs is 42. Which is like, wait, what? And that's the joke. Okay, so 42. We want to find all the zeros for the function. So how many zeros should we be looking for in this case? 3 zeros. Great. The possible rational zeros are easy in this case because the leading coefficient is 1. So they're just going to be the factors of 48, right? Now there's a lot of factors of 48, which is kind of unfortunate. But is it just 20? No, there's got to be, yeah. It's got to be just those ones. Okay, what do we do after this? Look at the picture to figure out what's going on. Okay, so there's that. Go ahead and look at my graph. Oh boy, look at all this stuff. Let's see. So I got what here. Let's write some of this down, right? All right, so we got 1, 2, 3, 4, 5, 6, 7. Looks like -8. And we got, I don't know, looks like -2.5-ish. And then it looks like positive 2.5-ish. Everybody's okay there with what we're seeing? Okay. So let's go check our list here to see if we see these x-intercepts from the graph on our list of possible rational zeros. I see -8 on there. Did you guys see -2.5? Or positive 2.5? What does that tell you about these answers? What does the R in PRZ stand for? Rational. So what kind of numbers are still real numbers because we can see the x-intercept, but are not rational? What are those kind of numbers called? They're called irrational. The only way we're going to find these is using the quadratic formula. So we know at some point we're going to have to use the quadratic formula to find those irrational zeros. So far, so good? So what are we going to start our synthetic division with? -8, right? It's the only one that was on our possible rational zeros list. Those are the only numbers that we can use that could possibly work when we do our synthetic division. So I'll just rip through this. Whoop. Whoop. Yeah. Big surprise that -8 worked. It's like, yeah, Mr. Kulik, I knew that was going to work. I saw the x-intercept for it. Why did I still have to do this? Well, Mr. Smarty Pants, because we needed these numbers. Remember, we have remainder, constant, x coefficient, and x squared. So what this tells me then is I can solve x squared minus 6 equal to 0. Why didn't you put the 0 there, Mr. Kulik? I mean, I could write 0x if you want me to. I mean, it's not wrong. But 0x is just 0, and 0 plus anything is just 0. So, like, why would I want to do that? I don't know. I just didn't feel like it. All right, quadratic formula time. X equals, what's the B? Nope.
Oh.
B is 0. Remember, B is the coefficient on x. What's A? 1. What's C? Negative 6. So this becomes the square root of 24 over 2. And again, we can simplify the square root of 24 because 24 is 4 times 6. And the square root of 4 is just 2. And if I, oops, I forgot my plus or minus there. And if I reduce that, I just have plus or minus root 6. And if you type that into your calculator, it is right around 2.5. Let's just confirm that for us. Look at that. Right around 2.5. That's the other x-intercepts we saw were plus or minus the square root of 6. Everybody cool? Let's write that down in our 0 box. Can I point out to one other thing to you guys here? For this one, since there's no x term, it was just x squared. Was there another way you could have solved this? Sure. You could have added 6 to both sides and square rooted both sides. That works only if you have no x term, like we did in this case. If you look at the previous example we just finished, you could not have done that trick because we do have an x term there, the negative 4x. There you had to use the quadratic formula. This one, you had an option. You could have solved it directly, like we did there in blue, or you could have used the quadratic formula like we did in green. Either is okay. The takeaway is quadratic formula always works. The other quadratic solving methods don't always work, but they're sometimes a little bit easier to handle numerically than the quadratic formula. What do you guys think? You want to just take some time and work on some of this problem set on your own? If you get stuck on things, feel free to come up and ask me about it, or be like, hey, I was doing this and I wasn't sure what to do next, or any of that jazz. Leo, what's up?
One question is, where did the I come from in the last problem?
Yeah, sure. So the I came from the negative under the square root.
Okay.
So the negative turned into the I, and then we just left the 12 where it was.
Doesn't I have to do something with like -2 also?
So I is equal to the square root of -1.
Yeah.
Is what that's equal to. So we could think about square root -12 as square root -1 times square root 12. So that's our I, square root 12. Does that refresh your memory? Yeah. Because we did this all last year, right?
Yeah.
But it was a year ago. And like stuff fades.
I never really made sense to me, but yeah.
Yeah. Well, here's the reason it doesn't make sense is because we just, like everything else, we just made it up. Because we needed a number to deal with the square root of a negative. It's like, okay, well, how are we going to deal with this? Well, this is how we're going to deal with it. We make up a new number. Imagine if you're a caveman, right? And it's the first time you've encountered 10 of something. You have to make up a new number for that. You're just like, I have a need. I had 9 sheep before, and this sheep had a baby. Now I have more than 9 sheep. I need a new number. Me call 10. You know, like, I don't know, it's just, you just made it up. It's the question, is mathematics made? Like, is it discovered or is it invented?
What's your opinion?
I would say our system of mathematics is invented. I think, like, the principles are discovered. So the way that we describe
like
the mathematics itself. Yeah, or the symbols we're using, or like the notation we're using, or the way we're communicating it. These are all invented. We decided how to do that. And it's evident throughout history that when you've seen cultures come together, you have like many notations to describe the same thing, because people's made the same discovery and then came together. It's like, oh yeah, we already know how to do this. This is what we call it. But like, it's not an accident that like cultures separated by wide geographies and isolated via communication come up with the same principles. Like they're doing algebra the same way. They're basically counting the same way. I think that lends so I think that says something. But that's just me. Others may disagree.